The universe has just shared a breathtaking secret with us. For the first time ever, the James Webb Space Telescope has captured a real image of a distant planet. Imagine the excitement. This is a genuine photograph of a world beyond our solar system. No simulation, just pure discovery. This is the moment astronomers have dreamed of, and their joy is written on every face. It marks a turning point in our quest to understand the universe and our place within it. Today, our curiosity has been rewarded with a glimpse of the unknown. This achievement is a tribute to human ingenuity and our endless drive to explore. The planet, named TWA-7b, circles a young star hundreds of light-years away. We are witnessing the dawn of a new era in space exploration, one filled with hope and wonder. The impact is profound, opening doors to understanding how planets form and the search for life beyond Earth. This is a breathtaking milestone. For the first time, Webb has captured a direct image of a distant planet, an achievement that will echo through history. TWA-7b now holds the title as the lightest exoplanet ever directly seen, an astonishing feat that once seemed impossible. This moment is a testament to the extraordinary power and vision of the James Webb Space Telescope. Webb has shattered expectations, reaching beyond the boundaries of what we dared to dream. It is a giant leap into a realm of planetary systems that were once hidden from our eyes. TWA-7b is about 10 times less massive than any exoplanet ever directly imaged before. An extraordinary leap in our capabilities. Webb has opened a new window onto worlds that were once beyond our reach. This discovery proves Webb can reveal the faintest, most elusive planets in the galaxy. For planet hunters everywhere, this changes everything. The universe just became more accessible, more real. Now we can begin to build a true census of the planets that fill our galaxy. Webb is capturing their portraits, turning distant theories into vivid reality. This is the dawn of tangible evidence, no longer just models but proof we can see. It's an exhilarating leap forward in our understanding of planetary systems, and a celebration of human curiosity. We are finding neighbors in the vastness of space. Now we can start to answer the deepest questions and piece together the grand puzzle of planetary evolution. It's about gaining a richer perspective on the cosmos, and our own origins within it. Welcome explorers to Space Vault, your gateway to the wonders of the universe. Here, curiosity is our compass, and every question leads us deeper into the cosmos. Today, we stand at the edge of discovery. Our understanding of the universe is being transformed before our eyes, and you are part of this incredible moment. The James Webb Space Telescope has, for the first time, directly photographed an exoplanet, TWA-7b. This marks a new chapter in our cosmic journey, one filled with awe and possibility. This is why we build magnificent instruments like Webb, to seek answers to the biggest questions humanity can ask. Today, Webb has lifted the veil, revealing the universe as never before. This extraordinary discovery is unfolding right now, in our lifetime. Join us as we explore why TWA-7b is such a monumental find, and how this single observation is rewriting the rules of exoplanet science. The vault of cosmic secrets is opening, and together we are witnessing history. Why does this discovery matter so much? TWA-7b is a key that unlocks a door previously sealed shut. This is the lightest exoplanet ever directly imaged, roughly the mass of Saturn. Before Webb, we were essentially blind to smaller, cooler, and more common types of worlds. Webb's sensitivity has shattered that limitation for good. This breakthrough fundamentally alters the landscape of exoplanet science from quantity to quality. Webb enables us to capture images of planets with masses similar to those in our solar system. We can now see the diversity of solar systems as they truly are. The discovery of TWA-7b is urgent because of what it represents for the future. This single success paves the way for a flood of new discoveries. Webb opens a new window of exoplanets that had not been accessible to observation so far. Ultimately, this matters because it brings us closer to home. We are looking back in time, witnessing the processes that may have led to the formation of Earth. It is about understanding our origins and our place within a vast and populated cosmos. The age of exoplanet photography has arrived, and it promises to change everything we thought we knew. To grasp why today's news is so groundbreaking, we need to understand the cosmic game of hide-and-seek astronomers have been playing. Finding a planet orbiting another star is incredibly difficult because stars are blindingly bright, while planets are astonishingly faint. Trying to spot an exoplanet directly is a challenge of almost unimaginable proportions. For decades, most exoplanets were found using indirect methods like the transit method. These methods only give us hints, not a picture. The dream of direct imaging is to bypass these limitations and just take a picture, which has been the holy grail of exoplanet science. That instrument is now a reality aboard the James Webb Space Telescope. How did Webb achieve the impossible, staring down the brilliant star TWA7 to find its tiny planetary companion? The answer? A coronagraph. Think of it as ultra-sophisticated sunglasses, creating a tiny artificial eclipse inside the telescope. It blocks the central star's light, revealing much fainter orbiting objects. The coronagraph is part of Webb's mid-infrared instrument, or MIRI. Webb's version is on another level, collecting more light in the cold, stable environment of deep space. Webb is designed to see infrared light, crucial because young planets like TWA7b radiate a faint amount of heat. This makes Webb uniquely suited for this task, far surpassing any previous observatory. This enabled the record-breaking discovery of TWA7b, a much smaller, cooler, and fainter world. This isn't just an upgrade, it's a revolution, opening a new frontier to hunt for planets like those in our solar system. This breakthrough with TWA7b represents a fundamental shift in exoplanet science, a move from deduction to direct vision. For years, astronomers have been building complex models of how planets form and evolve based on indirect data. They could infer a planet's mass, its size, and its orbit, but they couldn't truly see it. It was like trying to understand what an elephant looks like by only studying its shadow. You can learn a lot, but you will always be missing crucial information. Direct imaging changes that entirely. Now we can see the elephant. We can look at the actual photons coming from the planet itself, which is a complete game changer for the field. The image of TWA7b is more than just a pretty picture. It is a treasure trove of scientific data. By analyzing the color and brightness of this tiny dot of light, astronomers can determine the planet's temperature, estimate atmospheric composition, and look for clouds. This is the beginning of comparative planetology on a galactic scale. As co-author Matilda Mallon stated, this discovery is an exciting step forward in our understanding of planetary systems, including our own. We can now compare atmospheres of alien worlds to Jupiter, Saturn, and Earth, giving us invaluable context for our cosmic neighborhood. This leap from theory to visual proof is profoundly important. It validates our models and gives us the power to challenge them with real observations. Lead researcher Anne-Marie Lagrange pointed out that TWA7b's location is exactly where we expected to find a planet of this mass, based on the dusty debris disk surrounding the star. This confirms our theories about how planets shape their environments are on the right track. This single observation provides a critical anchor point for planetary dynamics, turning abstract concepts into observable reality. We are no longer just guessing, we are seeing. The demystification of direct imaging ushers in an era where we can explore the full diversity of the cosmos. As Lagrange said, Webb opens a new window to explore exoplanetary diversity and understand formation. We are no longer limited to perfectly aligned planets or massive wobble causers. We can actively hunt for planets, scan young star systems, and build a family album of galactic worlds. The age of discovery by inference is giving way to discovery by photography. The universe got bigger, and we have the eyes to truly see it. Let's turn our gaze to TWA7b, a world that has captivated the astronomical community. This is a portrait pieced together from faint light that traveled across the interstellar void to Webb's mirror. Imagine a world caught in its infancy, still glowing with the warmth of its creation. This cosmic infant offers a glimpse into the chaotic, formative years of a solar system. It orbits the red dwarf star TWA7 in the TW Hydra Association, a nearby stellar nursery. The system is incredibly young, just 6 to 10 million years old. This youth makes TWA7b so scientifically valuable. We're seeing a planet still evolving, interacting with the material from which it was born. TWA7 lies approximately 111 light-years from Earth. Webb's vision resolves the planet as a distinct point of light. The planet orbits its star at a considerable distance. Scientists estimate its mass to be roughly that of Saturn. We are seeing a world that feels familiar. The story of TWA7b gets even more compelling when we look at its environment. This planet orbits within a vast, dusty structure known as a debris disk, the leftover raw material from star and planet formation. Webb's images show that this disk around TWA7 has gaps and rings. Astronomers had analyzed the structure of TWA7's debris disk and predicted a planet should exist to create the observed gaps, and when Webb pointed its eye to that exact spot, there it was. TWA7b is a cosmic architect, allowing us to witness solar system evolution in action. By studying TWA-7b, we are watching a replay of events that likely unfolded in our own solar system billions of years ago. The image Webb captured is a snapshot in the intricate process of creation, allowing us to test theories that were once confined to computer simulations. Let's zoom in on the physical characteristics of TWA-7b. What would it be like to visit this nascent world? While we can't send a probe there, Webb's infrared vision gives us remarkable clues about its nature. As a young planet, TWA-7b is still radiating the immense heat left over from its formation, a process of violent collisions and gravitational collapse. Because of this residual warmth, it glows faintly in infrared light, which is how Webb was able to spot it. Scientists have analyzed this faint glow to estimate its temperature, and the results are intriguing. They suggest the planet has a surface temperature of around 120 degrees Fahrenheit, or 47 degrees Celsius. This temperature might sound surprisingly balmy, like a hot summer day on Earth. However, for a gas giant orbiting so far from its star, this warmth is not coming from starlight. It is the planet's own internal heat, a sign of its youth and ongoing contraction. Over hundreds of millions of years, TWA-7b will gradually cool down and fade, eventually becoming a much colder and dimmer version of itself, more like the frigid gas giants in our own outer solar system. We have caught it in a fleeting, warm phase of its life. This temperature reading is a critical piece of the puzzle, as it helps astronomers refine their models of how gas giants cool over time, a key factor in understanding their evolution. The fact that TWA-7b is a Saturn mass world, rather than another super Jupiter, is perhaps the most profound aspect of its profile. It proves that Webb can bridge the gap to normal-sized planets. Astronomer Anne-Marie Lagrange emphasized that this opens a new window on the diversity of exoplanetary systems. We can now start to ask, are Saturn mass planets common or rare in the outer regions of solar systems? Do they all form in a similar way? By finding and imaging more worlds like TWA-7b, we can begin to build a statistical understanding of planetary populations, moving beyond single discoveries to a comprehensive galactic census. This is how we will eventually determine just how special, or how ordinary, our own solar system truly is. So when you look at that single, humble point of light in Webb's historic image, remember what it represents. It is a warm, Saturn-sized world, a mere 10 million years old, orbiting a distant star 111 light-years away. It is a planetary architect, actively carving out its home from a sea of cosmic dust. It is a time capsule, showing us what our own solar system may have looked like in its infancy. And most importantly, it is a promise. To understand how Webb discovered TWA-7b, we need to discuss its superpower, seeing the universe in infrared light. Our eyes see a narrow band of light, but the cosmos is filled with invisible light, including infrared. Webb was designed to be an infrared observatory, making discoveries like TWA-7b possible. Infrared allows us to peer through cosmic dust and see hidden worlds. Young planets like TWA-7b radiate heat, emitting infrared light. Webb's detectors see this, hunting for thermal signatures of new planets. Analyzing infrared light, scientists deduce a planet's temperature. Webb's infrared vision unlocks a hidden universe. While infrared vision allows Webb to see the right kind of light, it still has to deal with the fundamental problem of exoplanet hunting, the overwhelming glare of the parent star. Even in the infrared, the star TWA-7 is millions of times brighter than its planetary companion, TWA-7b. This is where Webb's second superpower comes into play, its advanced coronagraph, the instrument that performs a delicate and precise artificial eclipse. This technology is the epitome of precision engineering. A tiny, sophisticated mask inside the telescope that blocks the light from the star without covering up the faint planet orbiting right next to it. It is an act of cosmic surgery performed with breathtaking accuracy. The coronagraph used in this discovery is part of Webb's mid-infrared instrument, or MIRI. It is not a simple shutter but a series of exquisitely designed masks that can be moved into the light path with microscopic precision. When astronomers lock onto a star system, they can command the coronagraph to create a perfect tiny shadow that falls exactly on the star. As described in a ZME science report, a coronagraph acts like an artificial eclipse. This technique effectively nullifies the star's blinding light, allowing the ancient faint photons from the planet TWA-7b, which have traveled for over a century to reach us, to finally be detected against a dark background. This technology has been used before, but Webb's implementation is revolutionary for several reasons. First, Webb's position in deep space, far from the blurring effects of Earth's atmosphere, provides an incredibly stable platform. On the ground, atmospheric turbulence causes starlight to twinkle and smear, making it nearly impossible for a coronagraph to perfectly block the light. In the pristine vacuum of space, Webb can hold its view steady, allowing the coronagraph to perform its function with unparalleled perfection. This stability is the secret sauce that allows Webb to dig deeper into the glare and find fainter planets than ever before. The combination of this precise coronagraph with Webb's infrared sensitivity is what led to this historic breakthrough. The team of scientists, led by Anne-Marie Lagrange, used this instrument to target the TWA-7 system and reveal the Saturn-mass planet that was 10 times fainter than any planet directly imaged before. This successful demonstration proves that Webb can now hunt for a whole new class of worlds, the cooler, smaller planets that were previously lost in the noise. This is not just a tool, it is a gateway. Webb's coronagraph is the superpower that has given us the ability to explore the inner sanctums of distant solar systems, transforming them from single points of light into places we can begin to explore. Webb's incredible discovery is underpinned by its magnificent primary mirror. 18 brilliant gold-coated hexagonal segments fit together to form a giant light-collecting surface. This mirror is the engine of Webb's power. A larger mirror can collect more light, allowing the telescope to see fainter and farther objects. Webb's mirror is the largest ever sent to space, giving it unprecedented sensitivity to the faintest whispers of light from across the cosmos. Each of the 18 mirror segments is a marvel of engineering, made of beryllium and coated with a microscopically thin layer of pure gold. This golden surface allows Webb to capture over 98% of the infrared photons that strike it. We found a record-breaking new planet, TWA-7b, that's only 10 million years old. Studying this young planet is like having a time machine, allowing us to witness the birth of a solar system. By studying infant worlds like TWA-7b, we can see planet formation unfolding. We get to see firsthand how a planet interacts with its cradle, watching as its gravity carves out gaps and gathers material. We are watching planets form in real time. TWA-7b is a planetary sapling, holding clues about the initial conditions of planet formation. Each new discovery adds another piece to the grand puzzle of cosmic origins. The processes we are witnessing are the same that shaped our solar system and Earth. TWA-7b is a ghost of our own solar system's long-forgotten youth. Young planets are cosmic time capsules, preserving information lost as they age. The heat detected from TWA-7b is the planet's own primordial warmth, a fading echo of its creation. This internal heat is a fossil record of its formation. A young planet's atmosphere is a pristine sample of the original nebula. A 10-million-year-old planet like TWA-7b lets us study a near-original atmosphere. Webb's spectrographs dissect their light, searching for chemical signatures like water and methane. This gives us an inventory of the building blocks of planets. This is a crucial step in connecting interstellar clouds to habitable worlds. Studying these planets helps us address how common solar systems like our own are. We can see the different paths that solar systems can take. We will build a complete picture of planetary diversity. The discovery of TWA-7b is just the beginning. Webb's real mission is to find habitable worlds. Now, Webb will target rocky planets in the habitable zones of their stars, searching for signs of life. Its spectrographs will analyze starlight passing through alien atmospheres, hunting for biosignatures like oxygen, methane, and water vapor. Each gas giant Webb images helps us understand which systems might support Earth-like planets. The techniques proven on TWA-7b are now being used to push the search for life further than ever before. The hunt for another pale blue dot is on. With its new capabilities, Webb is set to investigate a carefully chosen list of exoplanets, top of the list. The TRAPPIST-1 system with several Earth-sized planets in the habitable zone. Webb will analyze their atmospheres for water, carbon dioxide, and methane potential signs of life. Other targets include Beta Pictoris and HR 8799, where Webb will search for hidden, smaller worlds. Each observation will reveal more about the diversity of planets in our galaxy. The era of exoplanet discovery is just beginning. For decades, exoplanet science was built on indirect evidence, shadows and wobbles. Now, with Webb's direct image of TWA-7b, we have tangible proof photons from a distant world. This leap transforms exoplanets from abstract data points into real, observable places. Direct imaging validates our theories and grounds our models in reality. TWA-7b's discovery marks the shift from speculation to direct exploration. Exoplanets are no longer just numbers, they're destinations. The age of exoplanet photography has begun. Direct imaging with Webb launches a new era in planetary science. We can now compare planets across the galaxy, not just in our solar system. TWA-7b, found within its star's debris disk, lets us study planet formation in action. Spectroscopy will soon reveal the chemistry of these worlds, paving the way for astrobiology. Webb is turning distant concepts into real, studied places, showing our solar system is just one of many. We're building a true family album of the galaxy. The discovery of TWA-7b is more than science, it's a testament to human curiosity. Webb's success is the result of global collaboration uniting thousands in pursuit of cosmic answers. Like Galileo's telescope, Webb is transforming our view of the universe. This achievement inspires future scientists, artists, and dreamers alike. The image of TWA-7b is a symbol of what humanity can achieve together. Our journey into the cosmos has only just begun. This discovery is something you can be a part of. There are more ways than ever for students and enthusiasts to join the quest. Citizen science projects like Planet Hunters TESS invite volunteers to help professional astronomers sift through data coming from telescopes. For students who feel a calling to the stars, the path to a career in this field is clearer than ever. Pursuing studies in the STEM fields is the foundation for becoming a future astronomer. Your journey can start today, fueled by the inspiration of discoveries like TWA-7b. This is Space Vault, where we believe curiosity is the engine of discovery. Let us know your questions in the comments below. Be sure to subscribe to Space Vault and hit that notification bell so you never miss an update. Stay curious.